Hello everyone and welcome to another AP Computer Science video. This video is going to continue with some for loop examples. We've seen in previous videos that iteration is a very powerful tool to make things happen. Our programs can be very flexible in what they handle and we can minimize how much code we have to write. We make fewer assumptions, we make more robust code that can handle different situations, and while loops and for loops are a great way to do that. So we'll continue with a few more examples with for loops and why they might be useful. We'll do that. Go ahead now. So we'll start off. The last example we did is we reversed a string. This time, let's try counting the number of characters of a particular value in a string. So, for example, we're going to go ahead and make a string. We'll say something like string text. I don't know if we already used this, so we'll do that. Let's do string message is equal to, and we'll go ahead and put something in quotes. We'll say very exciting and challenging world of programming. All right, so there's our string, and it just has it's just a sentence, and the reality is I want to say, well, how many E's are in this sentence, or how many spaces, or how many L's or M's or anything, and then we might want to consider capital and lowercase words or characters. And so how could we go about this? The strategy is going to be very similar. In most situations, if you're going through a string, you're very likely to want to visit every single character, and so our loop is very common. And if the direction is not important to you, do you go from the front to the back, from the T to the exclamation point, from the exclamation point to the T? If that doesn't matter, then you can pick a direction, and typically you go from front, the first character, index 0, to the last character, index length -1, but it's not particularly important that you go one direction unless there's something about that helps. And in this case, it would not matter, because we're going to look at every character no matter what. So the order in which we see them is not that important to the situation. So let's try and do this. We're going to need a variable that's going to represent that count, and so we'll maybe say int count, and we'll start off at 0, because if we have a string that has nothing in it and we search, we should get 0 as an answer. And of course, it's possible that we look for the letter Z and there's no Z anywhere here, so we don't get an answer there as well. So it really does depend on what our situation happens to be. And so let's make a loop that goes through every single character in our string. And so we don't go through characters directly, we instead go through a number that represents the index of a character in our string. And we always know for any string of any size, the first index is 0 if there's a character, and the last index is always going to be the length of that string -1. So that gives us enough information to set up our for loop, either going backwards or forwards, whatever we choose to do. So let's do that. We can say for, which is our keyword, our initialization, which is always the first part of our loop. Typically, we make a sentinel variable. In this case, we use the int I. And again, I mentioned last time that I is kind of the standard for a single character variables that represent sentinels. This is common for loops, so this is kind of one of the few situations that you won't get harassed to make meaningful variable names. I is good enough for this situation, or J or K are common uses as well. And so we start off at equal to 0, because again, 0 is a valid index, and so we want to use that, and we do want to consider that first letter, and if we didn't, then we would maybe skip it, so we have to be very careful about that. The second portion of our for loop header is the condition. What must be true for us to continue our work? And so in this situation, the idea is, well, the same as before. We want to go through every character, so as long as the index, the I, is a good index, or a number that could be considered an index that's correct and not going to cause an exception, we can continue. So as long as I is less than the length of our message. Because if our message is 10 characters, let's say, then we want to go from 0 to 10, not including 10. Because if length 10 would imply that the last safe index would be 9. Because if you count from 0 to 9, that is 10 characters. And so we say less than. Could you also write less than or equal to the length of the string -1? And that's acceptable, right? That's okay too, because if you saw a string of length 10 and you said from 0 less than or equal to 9, because 10 minus 1 is 9, then that would be okay, because you would be including 9 but not going further. Do not mix those together. If you use strictly less than, then do less than the length. If you do less than or equal to, then you better make sure to do the -1. Any mixing of those will cause problems. And I'll change it on purpose after we're done just to kind of see the error that occurs. There's a particular exception that's very common for these kind of subtle mistakes in going out of bounds of the indices that are specified for whatever particular string we're working with. So there's our second semicolon for our condition, and the last part is the update. And again, we make a change, and in this case, typically to I, so that eventually the condition is false. And since the length of the string probably is not going to change, the I will, and therefore we should update I in some fashion. And since we're going from 0 to the end, it's going to go up by one number each time, because we're looking at every character. We're going to do I plus plus. And here it is. And let's go ahead and try doing retrieving a single character. And so we've done this before as well. It's a very common strategy, and so we'll go ahead and say string cur char, and I'll use the same variable as I maybe similar did before. And again, we're going to use substring, so we'll say message.substring. And again, if I'm at index I, then I want to go from I to I plus 1, because that will not include I plus 1, which will only be the value at index I, which is a single character. So I to I plus 1. And again, if I was 0, it would be from 0 to 1, not including 1, which would be index 0, the first letter. If I is 10, then it would be 10 plus 1, which is 11, not including 11, which would just be index 10. So there's our character. And then now we can ask, well, is it the letter we're looking for? And so we'll say for our example, we'll say count the number of the given letter. So what we should do is we should make another string, and we'll say string search. And we'll put a letter. So for now, we'll go ahead and put E. And we'll say we're looking for E's. And so we're going to say in our loop, we're going to say, well, if the thing I have, the current index, the value there, is equal to the thing that I'm searching for, then I should probably bump up my count. So let's ask that question. We'll say if the current char, which is a string, we compare strings not with the equal symbol, because that would compare references and memory addresses, but instead the equals method. And so we're comparing it to what we're searching for. And if that's true, then all we have to do is say count plus plus, go up by 1. And so this is a convenient thing to do. Now I'm going to point out something else that's not directly related to loops or if statements, but just in general, and I'll do it for the if statement here. One shortcut we could take in coding to make our code less spaced out, to minimize lines or take up less space if we're really worried about that kind of thing, is the rule that if an if statement or an else statement or an else if statement or technically a loop statement only has one line in the body, meaning between the curly braces, then strictly speaking we are not required to hold these curly braces. So in the example of the if statement on line 66, if the current char equals search, if all I'm going to do is increase the count by 1 and there's no other work to be done in this if statement, then I don't have to put these curly braces on 67 and 69. So I'm going to delete them and we'll see, and I'm going to go ahead and format it real quick. And there it is. So there is no curly brace. The assumption that the compiler makes is that if there is no curly brace, then the next line after the header of the if is going to be the body of the if. Now this is dangerous because if you have multiple lines, so for example, if I realized I wanted to count and then also print something, even if I trick myself by thinking this is correct, that would not be correct. Why? And it's going to potentially warn us. It says confusing indentation. It's smart enough to recognize, hey, you indented, which seems to imply that this is part of the if, but that's a lie. It's not correct. The reality is the if is not dictated by white space like a tab. It's dictated by the curly braces. And so the only part of the body would be the count. And so in reality, this is, whether it was like this or not, this is what would happen. The count would only happen conditionally. The print would happen no matter what. And so if we wanted to make both happen in the if statement, we'd have to have the curly braces. But again, it's a matter of style. If you are comfortable writing if statements that only have one line in their body without curly braces, do it. If you're comfortable using curly braces for everything, do it. It's better to be comfortable than to try to use something that you think looks slick or makes less lines. The number of lines in a program is not really important, generally speaking. It's not about smallest code. It's about effective code and clear to human beings in terms of what it does, its readability, its purpose. But I do want to point out we could definitely shrink code by slowly getting rid of curly braces if we don't need them and if we're comfortable with that. So I'm happy to write this as, well, if they're equal, then increase the count. Otherwise, do nothing, and it would just skip right past it. So what's the next step? Theoretically, this is good enough. Now, the only problem is that search may be a lowercase letter, but what happens if I want to find like the uppercase version or the lowercase version? Maybe we should handle that more gracefully. And so what we'll do is we'll say, instead of just saying search in our equals, we'll do something like search dot to lowercase. And in this situation, since they gave us lowercase e, nothing would happen. It would stay lowercase e. But now we can also do another comparison. We can say, or the current character is equal to or equals the search dot to uppercase. And now we're saying, well, whether they gave me a capital E or lowercase e, if I find a capital or lowercase e, I'm going to include it in my count. And then this is, again, a matter of, do you care about capitalization? And this is one way. There is another equals method called equals ignore case that basically does this for us, but I wanted to show you explicitly because while the AP exam doesn't test you on equals ignore case, they won't use it. You could theoretically use it if you wanted to. But this is the way that they would write their code if they had to write this. They would say, hey, well, technically they might not even use to lower or to upper, but if they did, then they would do it maybe in this fashion. So if this is correct, we can count however many letters there are, and then let's print out the number of e's. So we'll say, let's print out, we'll say number of, and what I'm going to do is I'm going to attach whatever letter they gave us, so search, and then I'm going to attach an apostrophe s. So if it's e's or b's or z's or whatever letter it is, and then we'll do this and put a space, and then we'll attach the number that we got, which in this case is count. So let's run it. And we can count really quickly. 1e, 2, 3, 4, 4. We expect to see 4 is, I think, the answer for e. Well, I broke something, and so we should figure that out. So what did I do wrong here? Oh yeah, so I left it here. I forgot that I had left this here. We said I is less than or equal to message.length. And if we look at the actual output, the name of this exception, because many exceptions have very kind of wordy names to make it clear as to what went wrong. It says string index out of bounds exception. It says, look, you tried to use an I. The loop itself is not the problem. You can go from zero to length. But when you use a number that's not in the range of the indices, then the method substring will fail. And we can see it has kind of this backwards. When we look at it, it says string index out of bounds exception was caused. You began with 55, ended 56, but you put 55. I'm sorry, you put 56, but you end, but the last character is 55. Right? So that's a problem. And it mentions a bunch of stuff, but essentially it boils down to the substring method is what failed because we may have put an I that was too large. So let's correct this, and I said, if we're going to do length, then we do strictly less than. So let's go and run it again. And there it is. There's the number of e's is 4. Let's change this to p's. And if we look at this, there's only one p and it is capital, but I put lower, so we should hopefully still get the right answer of 1. And there it is, because it ignored the capitalization because our if statement was very friendly in terms of what it compared. It said capital or lowercase. Let's do another letter. Let's do G, or actually M. So let's see. We do M. There are 2. There's only the 2 in programming. And let's do one more. Let's do G. And there are 5 G's, right? The exciting, that's 2, 3, 4, 5. And now let's test this on a different string. If I do the number of G's in an empty string, I would hopefully get 0 and not a crash. The answer is 0. Because a loop that goes, if the length is 0 of an empty string, from 0 to 0, is 0 less than 0? No. So the loop runs 0 times. So for loops, just like while loops, may run 0 times. They may run 100 times. They may run infinitely, which is also a potential problem. But the idea is that the possibility is they can run potentially 0 times, and we have to accept that. Because the first thing that occurs after the initialization is the check of the condition. If we did the body without checking, that would maybe be different, but the reality is that we must check our condition first, and that's what happens. And so this works out nicely for us if we do it this way. And there it is, the number of g's is 5. So this is kind of a quick example of how a loop might be very useful for strings. And again, string manipulations are very common. We haven't gotten, there's another topic we'll discuss that will use loops in an even more aggressive manner, and for loops are often very helpful with that. But the idea is that any kind of problems we may face, a loop, whether it's a for or while loop, essentially allows us to control those number of iterations. And at the end of the day, you pick the one that you're most comfortable with. So I think that we're going to stop here. This is kind of a very brief video, and if you have questions about for loops, you can always ask, reach out to me. But we'll see in the next few videos and lessons that we're going to take this to another level, and we'll be using these quite a bit for a lot of different complicated situations. So I'll stop the video here, and I'll see you in the next video.